University. Today's topic is absolute configuration. Absolute configuration means the actual arrangement of atoms or group of atoms in space of a particular stereoisomer of a compound. RS configuration is a type of absolute configuration. The RS system is an important nomenclature system for denoting enantiomers. This approach labels each chiral center R or S according to a system by which its substituents are assigned a priority according to Kahan-Ingold Prelog priority rules. Kahan-Ingold Prelog is named after the British chemist Robert Kahan and Sir Christopher Ingold and Swiss chemist Vladimir Prelog. According to CIP rules, CIP rule is a combination of few rules. The rule number one is, firstly, we have to prioritize the four groups around the chiral center according to the atomic number. Means the group that has maximum atomic number gets the priority 1, and the group which is lowest atomic number gets the priority 4. In the given example, the bromine, which has atomic number 35, gets the priority 1. Then the chlorine, which has atomic number 17, gets the priority 2nd. Then that is CS3 group that has atomic number 3 gets the priority 3, and the hydrogen gets the priority 4. It means that we have to assign the priority according to the atomic numbers. In rule second, if atomic number is same, then go for the atomic masses. As shown in the given example, here is fluorine, that is priority 1 because it has the highest atomic number out of the 4 substances. Then there is hydrogen, deuterium, and tritium. These are the isotopes of hydrogen. In this case, tritium has the highest atomic mass, therefore it gets priority 2nd. Then there is a deuterium which gets priority 3, and hydrogen, which has least atomic mass, gets the priority 4. Rule number 3: if the priority cannot be decided by the atoms that is next attached to the chiral center, then we have to move to the next atom. As shown in the given example, carbon, this is the central carbon, this chiral carbon, it's attached to bromine. Bromine has highest atomic number out of 4, therefore it gets priority 1. But out of CH2Cl and CH2CS3, the central carbon atom is attached to carbon atom in both the cases. In these cases, we have to move to the next atom, that is chlorine and CH3 group. After chlorine and CH3, the chlorine has the highest atomic number as compared to higher atomic number as compared to CH3. Therefore, group CH2Cl get the priority 2nd, and CH2CH3 that get priority 3. And the least atomic number is of hydrogen, therefore it get priority 4. Rule number 4: if there is a presence of double bond or triple bonds or the phenyl groups, in this case, double bond means the duplicate of carbon atoms. Triple bond means triplicate of carbon atoms. In this case, as shown in the given examples, double bond means this carbon atom is attached to 2 carbon atoms. As shown in this example, that is, this carbon atom is attached to 2 carbon atoms. Triple bond means that the carbon atom is attached to 3 carbon atoms. That is, this carbon is attached to this carbon, and this carbon. In the case of benzene ring, that is, carbon atoms attached to 3 carbons. Because there is a large number of carbon atoms in case of benzene ring, therefore it gets priority 1. Triple bonded group is get priority 2nd, and double bonded gets the priority 3rd. Fourth rule is that if there is a presence of atoms and lone pairs, then we have to use this rule. In this rule, the atom is, if priority of the atom is greater than that of the lone pairs and the charge. As shown in the given example, we have NH3 group and we have NH2 group. NH3 group, 3 positive group, has extra hydrogen as compared to NH2 group. Therefore, the NH3 group gets higher priority as compared to NH2 group. Therefore, NH3 group get priority 1, NH2 group get priority 2nd. Similarly, we have COOH group and COO negative group. In this case, COOH has extra hydrogen, and the atoms get higher priority as compared to lone pairs or negative charge. Therefore, COOH group get priority 3, and COO negative get priority 4. The next rule is that after assigning the priority to the substituents, we have to rotate the molecule until the lowest priority substituent is in back or below the plane. Number 7, draw a curve from 1 to 2 and 2 to 3 substituents as shown in the given example. We have to draw a curve from priority 1 to priority 2 and priority 2 to priority 3 as shown in these examples. The next tool is that if the curve is clockwise, after drawing the curve, if the curve is clockwise, the stereo center is of R configuration, and if the curve is anti-clockwise, counterclockwise, it means that the stereo center has S configuration, as shown in the given examples. In the given example, bromine get the highest priority, number 1 priority, chlorine get priority 2, CS3 get priority 3, and hydrogen get priority 4. And we have to draw a curve from 1 to 2, 2 to 3, and 3 to 4 like this. It is clockwise, therefore the stereo center is got configuration R. In the next example, we have bromine that is priority 1, we have chlorine get priority 2, and hydrogen get priority 4. We have to draw a curve or rotate the steering of the wheel from 1 to 2, 2 to 3. It is of anti-clockwise, therefore it get priority, therefore it get configuration S. There are some examples. There are few examples are divided into some cases to solve the example easily. Case 1. In this type of examples, when the lowest priority substituent is below the plane, we have to use this method when the lowest priority group is below the plane. As shown in the given examples, the bromine get the priority 1, Cl get priority 2, and CS3 get priority 3, and hydrogen get priority 4. It is a simple example. We have drawn a curve, and this curve is clockwise. Therefore, the chiral center is of configuration R. In the second example, the hydrogen atom is once again below the plane. Therefore, we simply prioritize the substituents and draw the curve. The curve is anti-clockwise. That's why it gets priority S. In case 2, when the lowest priority substituent is above the plane, because the molecules are given different configurations. If we have this type of molecules in which the lowest priority group or atom is above the plane, we have to apply the same rules as in the previous example with some changes. Firstly, we have to prioritize the atoms according to their atomic numbers. Therefore, bromine get atomic number 1. Bromine get priority 1, chlorine get priority 2, CS3 get priority 3, and hydrogen get priority 4. But in this case, the hydrogen atom that is least priority substituent or group is above the plane. In this case, we have to prioritize as in the previous case and similarly draw a curve. In this case, the curve is of clockwise direction. When the curve is of clockwise direction, there is R configuration, but there is hydrogen above the plane, so we have to convert the obtained configuration to opposite configuration. In this case, we get the configuration R, so we have to convert R to S. Simple meaning is that if we have a molecule which have lowest priority group above the plane, we have to follow the same rules and same configuration and convert that configuration to its opposite configuration. As shown in given example, it has R configuration normally, but hydrogen above the plane, therefore we convert R to S. Case 3. In this type of molecules, when the lowest priority substituent is in plane. In first case, lowest priority substituent is below the plane. In second case, the lowest priority substituent is above the plane. But what will happen if the lowest priority substituent is in plane? In this case, this lowest priority group is in plane. In these cases, we have to interchange the lowest priority group and the group that is below the plane. We have to interchange these groups. In the given example, bromide is below the plane and hydrogen in plane. So in first step, we have to interchange hydrogen and bromine. As shown in the given example, we have to interchange bromine and hydrogen. After that, we have to interchange the rest of the groups. We have to interchange chlorine and CS3. After these two interchanges, we have to draw a curve As shown in the example, that is we have to prioritize the bromine, that is 1, chlorine get priority 2, and CS3 get priority 3. Draw a curve. The curve is of clockwise direction, therefore it has R configuration. Now let us solve some example. In the example number 1, firstly we have to prioritize the groups. So oxygen has higher atomic number, therefore it gets priority 1. Sorry, the fluorine has higher atomic number, therefore fluorine get priority 1. Oxygen get priority 2, and CS3 get priority 3, and hydrogen get priority 4. Now draw a curve from 1 to 2, 2 to 3. It is clockwise, therefore it get R configuration. Next example, similar type of example, bromine get priority 1, and then oxygen is attached to the central carbon, therefore it get priority 2. Out of CS3 and CH2, Cl, carbon atoms are same atomic number. In this case, we have to go for next atom that is attached to carbon. In this case, we have chlorine, and in this case, we have only hydrogen. Chlorine has higher atomic number, therefore this group, that is CH2Cl, get the higher priority. Therefore, it get priority 3, and CH3 group get priority 4. Now draw a curve from 1 to 2, 2 to 3. The curve is clockwise direction, therefore the configuration is once again R. In the next example, we have to prioritize according to atomic numbers. Therefore, bromine get priority 1, chlorine get priority 2, CS3 get priority 3, and hydrogen get priority 4. Draw the curve from 1 to 2, 2 to 3. The curve is of clockwise, therefore it gets configuration R. But the lowest priority group is above the plane, therefore we have to convert the obtained configuration to its opposite configuration. Obtained configuration is R, so we have to convert R to S. Therefore, the exact configuration for this molecule is S. In the next example, similarly, the chlorine get priority 1, OH group get priority 2, and CH3 group get priority 3, and hydrogen get priority 4. Now draw the curve from 1 to 2, 1 to 2, 2 to 3. It is of anti-clockwise direction, therefore it gets priority S. But the least priority group, that is hydrogen, is above the plane, so we have to convert S to the configuration from S to R. So exact configuration is R. Now in the next example, assign the priority. Firstly, bromine get priority 1, chlorine get priority 2, and CS3 group get priority 3, and hydrogen get priority 4. In this case, the lowest priority group is in plane. So firstly, we have to interchange the group that is below the plane with the lowest priority group. CS3 group remains as it is. In this case, hydrogen is in plane. Interchange the hydrogen with bromine so that hydrogen becomes below the plane and bromine becomes in plane. And chlorine and CS3 group remain as it is. In the next interchange, we have to interchange the rest of groups. Bromine remain as it is. Hydrogen remains as it is below the plane, and we have to interchange the rest of group, that is chlorine and CS3. Now CS3 get the position above the plane, and chlorine get the in plane position. Now we have to prioritize the groups. Bromine get priority 1, chlorine get priority 2, CS3 get priority 3, and hydrogen get priority 4. Draw a curve from 1 to 2 and 2 to 3. It is clockwise, therefore the configuration is R. Thank you very much.